Here's a very interesting trigonometric equality. And if you're a student who's about to take the high level IB in maths, and if you're quite confident with trigonometry, I think trying to push yourself a bit further would be beneficial. And this is a very good question, which sort of pushes your boundaries a bit. Because if you look at it, this is one equation with two unknowns. And usually we can't really find what the unknowns are if we have uh, a number of equations less than the number of unknowns, right? So you can give this a try and I will start solving it here. Now, if you'd like to see anything similar to this on the channel, let me know in the comments, okay? So because we have fewer equalities than, or fewer equations than the number of unknowns, it means there must be a trick going on, okay? And we can sort of see something going on here. We can see that there's a cosine squared of x, we see there's a cosine squared of y. So if this term had a 2 in front of it, then we could very easily complete the square and get something out of it. Okay, but that's not the case. So let's try this. So we will write cosine squared of x. Now, for the second term, I will write it like this. So this is going to be 2 multiplied by cosine of x. And instead of just cosine of y, just if we want to get this term back, then if we multiply with a 2, now I have to multiply with a half or divide by 2, right? So this is going to now be 1/2 cosine of y. So why would we do that? Well, let's have a look. Now, this cosine squared of y, I'm not going to write it like this yet. Instead, I'll write it as 1/2 cosine of y squared. So I'm basically writing this as this. And of course, the cosine of x was already squared here. Okay. Now, to get back the cosine squared of y, I just need to add the 3/4 cosine squared of y. Okay, so now our equation is the same as the one we started with, except we rewrote it in a slightly different way. Okay, now this first part here, this is essentially a squared plus 2ab plus b squared, right? It has exactly that form. And as you know, this is just a plus b squared. Okay, so we're basically completing the square, and the first part of the equation is going to be cosine of x, and then plus 1/2 cosine of y, everything squared, and now we just have this leftover term. Okay, but we can also turn that into a square as well, and it's quite easy. So that last term is the square root of 3/2 multiplied by cosine of y squared, and the whole thing is equal to 0, right? So something interesting is happening. We have a sum of two squares which is equal to 0. So the only time when a sum of two squares is equal to 0 is when both terms are equal to 0, right? Because as you know, any real number, when you square it, you'll get a quantity which is at least 0. And it's 0 when the number itself is 0. Okay, and if we're adding multiple squares and the sum is 0, this is only possible when each individual term is 0. Okay, so let's look at this here. So this term is √3/2 cosine of y, and this is equal to 0, which of course means that cosine of y is equal to 0. Okay, and what we're going to use now is this. So for cosine of x equals a, where a is any number between -1 and 1, right? Then x is given by plus or minus arc cosine of a plus 2k pi, where of course k is just an integer. And that's exactly what we're going to use here. So in our case, we have cosine of y is equal to 0, which means that y will be equal to plus or minus arc cosine of 0 plus 2k pi. So this is plus or minus, and we know that arc cosine of 0 is just pi over 2, and this is plus 2k pi. So y can be any number as long as it has this form. So it's plus or minus pi over 2 plus an integer multiple of 2 pi. Okay, and then let's look what x is. So now that we found y, we can move on to this term, which is another perfect square, and we get that the quantity underneath the square has to be 0. So this plus 1/2 cosine of y equals 0. Now, we know that cosine of y has to be 0 because that's the second term, which means that this term cancels out, which means that cosine of x is equal to 0. So we get the same thing, right? So we have x is plus or minus pi over 2 plus, now I'm not going to use k anymore because x and y are independent from each other. So this is going to be, let's say, 2 multiplied by p multiplied by pi, where p is just another integer. Okay, and that's it. So we found x as plus or minus pi over 2 plus an integer multiple of pi, and we have y as plus or minus pi over 2 plus an integer multiple of pi. So I'm using different names for those because they don't have to be equal to each other. So even when p and k are just completely different integers, uh, x and y are going to be solutions to our original problem. And that's the end of the question.